Good morning. Today we're looking at Pascal's triangle and using it to get our coefficients when we expand binomials. Now, I'll explain that second bit shortly, but Pascal's triangle literally starts with the 1, and then 1, 1. And then we go and we add the numbers diagonally above it together. So for example, 1 plus 1 equals 2. My next one, I've got 1, 3, 3, 1, because, well, 1 plus nothing is 1. 1 plus 2 is 3, 2 plus 1 is 3, and 1 on its own is 1. Likewise, 1, 4, 6, 4, 1, 1, 5, 10, 10, 5, 1. Wish I'd left myself more space. 1, 6, 15, 20, 20, 6, 1, etc. The reason this is useful is because, do you remember how when we had a plus b squared, it came out as a squared plus 2ab plus b squared? Well, I could have had a 1 in front of the a and a 1 in front of the b. What do you notice about the numbers that we've got going on? Well, this 1, the 1, the 2 and the 1 literally come from here. So 1, 2, 1. If I have a plus b cubed, well then that's the same as a plus b, a plus b, a plus b. So that's the same as a plus b squared times a plus b. I know a plus b squared, it's a squared plus 2ab plus b squared times a plus b. Expand this out, I get a cubed plus 3a squared b plus 3ab squared plus b cubed. And if I had a plus b to the 4, then that's the same as a plus b squared times a plus b squared, a squared plus 2ab plus b squared, a squared plus 2ab plus b squared. Now you can expand these step by step later, but that's going to come out as a squared plus a to the 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4. So the coefficients again are coming from my lines here. You can tell that they're the same because that's a 1, 4, 6, 4, 1. So these rows of Pascal's triangle tell us the coefficients of our expansions. Now, if you have a look closer at each term, you'll notice that my a's start at 4 and they go down each time. And then there's nothing here. And my b's start off with nothing and they go up each time. You'll also notice that if you add the powers for each one, so we've got a to the 4 on the left, that's fine. 3 plus 1 equals 4, 2 plus 2 equals 4, 1 plus 3 equals 4, and 4 equals 4. You'll notice that they add up to the 4 that we're raising it to each time. Let's put this into practice. I'm going to go through all of these worked examples. So, for the first one, we have 1 plus 2a to the 6. Now, the way I like to do this is if I'm doing it to the 6, red. I will start off by putting down my coefficients and I'll give them enough space in between so I can put stuff in. So my coefficients are 1, 6, 15, 20, 20, 15, 6, and 1. Then we're going to multiply them all afterwards. And we're going to be adding each of these terms together. Okay, I start off with the leftmost value. I'll do this in pink. So I start off with this 1. So here I've got 1 to the 6. 1 to the 5, 1 to the 4, 1 to the 3, 1 to the 2, 1 to the 1, and 1 to the 6, 5, 4, 3, 2, 1. Oh, I shouldn't have had two 20s. It should have been 15, 6, 1, which means I've got too many terms. Ugh. 15, 6, 1. Okay, 1 to the 3, 1 squared, 1, and then nothing. My next ones I'm going to put in is 2a's. Technically this first one is 2a to the 0, but we don't even bother writing it. We just start off at the second from the left. So times 2a to the 1, 2a squared, 2a cubed, 2a to the 4, 2a to the 5th, 2a to the 6th. So if I go through and highlight, that 6 meant that I was in this row here, which meant I had 1, 6, 15, 20, 15, left way too much space, 6, and 1. This 1 here was this 1 to the 6, 1 to the 5, 1 to the 4, 1 to the 3, 1 to the 2, 1 to the 1, and then it disappeared. And this 2a gave me, well, it disappeared at first, and then 2a to the 1, 2a squared, 2a to the 3, 2a to the 4, 2a to the 5, 2a to the 6. Now we've actually got to figure out all these terms. So 1 times 1 to the 6 is 1, plus 6 times 1 to the 5 times 2a to the 1, we've got 6 times 1 times 2a. Then 15 times 1 times 2a squared gives me 15 times 1 times 4a squared, because you square each of them. My next term, I've got 20 times, well, 1 to the 3, 1, times 2a cubed is 8a cubed, because 2 to the 3 is 8. And then I've got 15 times 1 times 2 to the 4 is 16, a to the 4. And then I've got 6 times 1 times 32a5. And I've got 1 times 64a6. Okay. So I've got 1 plus 12a plus 60a squared plus 160a cubed plus 15 times 16. Oh gosh, I really don't know this. 10 times 16 is 160. 5 times 16 is 80. 160 plus 80, 240. A to the 4 plus, that's a 4. 6 times, 32 times 6, 12, carry the 1, 19. 192 a to the 5. And then I've got 64 a to the 6. And that's where it ends. Let me get rid of my embarrassing having to multiply. So just to kind of colour code where each of these things went, this 1 times 1 to the 6 was here. This 6 times 1 to the 5 times 2a to the 1 was here. This 15 times 1 times 2a squared here. This, I'm just trying to find different colours. 20 times 1 to the 3 times 2a cubed is that one. This 15 times 1 squared times 2a to the 4 is that one. This 6 times that one is that one. And what's colour I haven't used yet? This one is this one. And then if you do have like terms, you'll put them together, but we didn't. Instead of doing B, I'm going to do C because B is fairly simple and C is harder, but it's the same principle. Okay, so for C, now I'm going to write out my question. I've got 1 take 2/3 x to the 5. There's a trick with these. First of all, as usual, to the 5, we pick out our row. So it's the 5th row, so it's going to be 1, 5, 10, 10, 5, 1, okay? Now, plus, 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 times, 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 times. As usual, we've got 1s to start with. This is nice and easy. 1 to the 5, 1 to the 4, 1 to the 3, 1 squared, 1. I think I'm going to need more space over here. Okay. Let's put a times in after each of these. Oh, I already did. Okay. Now let's put this whole thing in. So that negative belongs with what we're doing. Negative 2/3 x. Oh, well, that would technically would have been to the 0, so we don't put it in there. But we do definitely put it in the next one. Negative 2 on 3x. Negative 2 on 3. Oh, I need room. X squared. Negative 2 on 3x cubed. Negative 2 on 3x to the 4. Negative 2 on 3x to the 5. Okay. So let's track where all these numbers went. These first ones were all from Pascal's triangle, the 5th row, because we're raising it to the 5. Oh, these ones were all because we were doing 1 to the whatever. Our first term was 1. You won't always get the first term as 1. In fact, they're being exceedingly nice if it is. These second ones were these ones. And we kept the minus with it. Okay. Let's now figure out each of these. So 1 times 1 to the 5 is 1 times 1 plus 5 times 1 times negative 2/3 x plus 10 times 1 times, now negative 2/3 squared is positive 4/9 and then x squared plus, now I've got 10 times 1 times, now negative 2 to the 3, and negative 2/3 to the 3 is negative 8 on 27 x cubed plus 5 times 1 times, now negative 2/3 to the 4, you can do these on your calculator by the way, is positive 16 on 81 x to the 4 plus 1 times, now negative 2/3 x to the 5, negative 32 on 243 x to the 5. Okay, now let's figure out what each of these is. 1 times 1, 1. 5 times 1 times negative 2/3 gives me negative 10 on 3, and then I just have an x. 10 times 1 times 4/9 is plus 40 on 9 x squared. 10 times 1 times minus 8 on 27 gives me negative 80 on 27 x cubed. 5 times 1 times 16 on 81 gives me positive 80 on 81 x to the 4. 1 times minus 32 on 243 minus 32 on 243 x to the 5. And that's how you do those ones. I'll do harder versions in the next video.